Hi and welcome to my YouTube channel. If you're new here, please subscribe and consider leaving a like. In today's video, I'm going to show you how to use the joystick module with an STM32 microcontroller. My name is Ali and you're watching Circuit Gator HQ. To get started with the code, open up STM32CUBEIDE and click on create a new STM32 project. Then go to board selector and type in the part number of the microcontroller that you're using. Then click on the microcontroller and then click on next. Then for the project name, you can just call it joystick and then click on finish. We're going to initialize everything ourselves. So go to pinout and then click on clear all pinouts. The joystick module has 5 pins: the ground, the 5 volts, VRX, VRY and the switch. The VRX and VRY are the potentiometer analog values for registering the values when we move the stick in the X and the Y directions. And then there's also a push button next to the stick that sends out digital signals from the SW pin. We need to go to system core and then under system, under debug, we need to select the serial wire and then go to RCC under high speed clock. Make sure that the crystal ceramic resonator has been selected and then go to clock configuration and make sure that your microcontroller is running at its maximum clock speed. Then go back to pinout and configuration and then go to analog and then select ADC 1. We're going to read ADC values in multi-channel mode using direct memory access. So select channel 0 and channel 1 and then take note that channel 0 is connected to pin PA0 and channel 1 is connected to pin PA1. Then we're going to go over to parameter settings and then we're going to enable the continuous conversion mode. Then scroll down and then here where it says number of conversions, we need to change this number to 2 since we'll be reading both the X and the Y values. Then expand where it says rank 1, make sure that it says channel 0 and then you can just select 480 cycles for the sampling time. Then we're going to do the same thing for rank 2, but we're going to change this one to channel 1 and then select the same number of cycles for the sampling time. Then go over to the DMA settings and add a new DMA request and then select ADC 1. Then for the request settings mode, click circular and then for the data word, you need to select a word. Then for the priority, we can just set it high for this project. Then we're going to go back to the parameter settings and then under DMA continuous request, we need to click enable and then go over to system view under NVIC, click the ADC1 global interrupt and then set the preemption priority to a value of 1. We then need to configure one of the GPIO pins as an input. So you can choose any pin that you'd like. So I'm just going to use pin PA8. So click on the pin that you'd like to use and set it as a GPIO input. Then under system core, go to GPIO and then select here where it says GPIO mode. And then for GPIO pull up or pull down, we're going to pull our pin high in the code. After reading the X and Y ADC values and the button press value, we need some sort of terminal where we can view this information that we're reading. For that, we can just use UART communication. So go to connectivity, click on UART, and then under the mode, click asynchronous. We don't need to change anything here. One thing that you need to do is just take note of the baud rate. Then click on Ctrl and S to save, click yes to generate the code, and then click yes to switch to the new perspective. In the main C file, scroll down to where it says private includes and then under user code begin includes, we're going to add 2 header files. The first one is going to be hashtag include stdio.h header file and then the second one is going to be the string.h header file. Then you can scroll down to where it says private variables and then under user code begin PV, we're going to initialize a few variables that we're going to use in our code. The first variable that we need to create is for storing our X values. So we need to say uint16_t and then we can just call our variable X value. And then we need to copy this line of code, paste it here, and then we can call our second variable Y value. The reason I'm initializing these variables as 16-bit integers is because our ADC is a 12-bit ADC. So we need to create a variable that is large enough to hold this information. Then we need to create a third variable that is actually going to contain the raw ADC values before we separate them into the X values and the Y values. So we can just say uint32_t and then we can call this one read value. And then to register the button click from the joystick module, we need to create one more variable that is going to store the digital values that show whether the button has been clicked or not. So you need to say uint 8 underscore t, and then we can call this variable button underscore state. And then when we're done capturing all of these values, we need to transmit them via serial communication so we can see the values that we're reading. So I'm just going to create a character buffer, and then I'm going to give it a size of 50 bytes. And then we need to scroll all the way down to where it says user code begin to. Then this is where we're going to start our ADC in DMA mode. So just say HAL underscore ADC underscore start, hold on control and click space, and we see that we have a couple of options for studying our ADC. And then just double click on this one that says DMA, click on ADC1, and then click on red value. But we need to pass this value, so I'm going to say uint 32 underscore t, and then I'm going to point to the address of this variable. And then for the length, we can just give it a size of 2. And then we need to go back here under the red value. We need to actually give it a size of 2 bytes, since it will contain a combination of both the x values and the y values. Then when this is done, go to user code begin 3. Here we're going to write the logic for capturing the ADC values, as well as capturing whether the button has been pressed or not. So I'm going to create a for loop, and then inside of our for loop, I'm going to say uint 8 underscore t I is equals to 0. Then I'm going to say I adc1.init.number of conversions, and then I'm going to say I plus plus. At this point in our code, the ADC values have been captured and have been stored inside of the read value variable. So to separate them into the x values and the y values, I'm going to say x value is equals to uint 16 underscore t, and then I'm going to copy the name of that read value, paste it here, and then I'm going to read from the first index. Then I'm going to copy this code, paste it here, and then I'm going to read this one from the second index and store inside the y value variable. When we're done reading the x and y values, we need to read the button press. So I'm going to say button underscore state is equals to HAL underscore GPIO underscore read pin, and then it's GPIO A, and then I'm using pin PIN underscore 8 for pin PA8. When we're done reading all the values, we need to prepare them for serial communication. So I'm going to say SN printf, and then I'm going to put the values inside the buffer variable, and I'm going to say size of our buffer. Then I'm going to add some text so that we can see which values belong to which x value, and then I'm going to add a %d, and then I'm going to copy this, paste it here, and then change this one to y value, say button, add another percentage and a d, add a /r/n, so we can start printing from a new line. And then I'm going to add the corresponding values. So I'm going to add the x value variable here and the y value variable, and then lastly I'm going to add the button state variable. I'm going to transmit the data via UART. I'm going to say HAL underscore UART underscore transmit, hold on control and space, and we see that we also have a few options for transmitting data. We're just going to click on the first option, click UART2, and the data that we're going to transmit is the data that is now stored inside of our buffer variable. But then before that, I'm going to pass this value and by saying uint 8 underscore t, and then I'm going to point to our variable. And then for the size, I'm just going to say size of our buffer variable. Then for the timeout, I'm going to say HAL underscore maximum delay. And then I'm going to add a small 300 millisecond delay so that we don't overload our serial terminal app. And then when that is done, I'm going to build the project so that we can see if there are no errors. Then when it says it's finished building with 0 errors and 0 warnings, you can just plug in the microcontroller into your laptop. And then when it comes to the circuit connections, they are very straightforward. You just need to connect the ground on the joystick module to ground on your microcontroller, and then connect the VCC pin to 3.3 volt on your microcontroller. It's very important to use 3.3 volts instead of 5 volts so that there can be a clear distinction between when you move to the lower X or Y values and to the higher X or Y values. If you use a larger voltage, you won't have a decent range. So since our ADC values are 12-bit, it means we can expect the maximum value of 4095 when we read the ADC values. So by connecting the VCC pin to 3.3 volts, we can expect our X and Y values to be around half of 4095, so around 2000 and something. And then they would either increase or decrease when we move the joystick module to the left or to the right or up and down. Then click on the Run button, select the debugger, then click on ST-Link, and then click on Scan, click on Apply, and then click on OK. Then when the code has been successfully uploaded to your microcontroller, open up your serial terminal app. I'm going to be using Party for this video. And then now we need to check the COM port and the speed. So the speed, which is currently set to 115200, must match the baud rate we took note of when we were initializing serial communication. So it needs to match with this value here. And then when it comes to the COM port number, go to Device Manager and then go to Port, and then you should see the port number under ST Microelectronics. Mine is going to be COM port 10. So now going back to the serial terminal app, I need to change this to COM port number 10, and then I'm just going to go to Appearance and then increase the font size so it's much more readable on screen, and then click on OK, then click on Open. And then as you can see, we're currently reading both the X values, the Y values, and we're also reading the button state. The reason we're getting a 1 in the button state value is because we pulled our GPIO pin PA8 that is connected to the switch terminal on the joystick module high. So it's going to read a value of 1, and then when it registers a press on the button, it's going to output a value of 0. Then we can also see that when I move the joystick to the right, the X value decreases closer to 0. And then when I move it to the left, it increases all the way closer to the maximum value, which is 4095. So that is the range that we can expect in those values. And then when I move the joystick up, we get a value that is closer to 4095 on the Y values. And then when I move it down, we get a value that is closer to 0 on the Y values. So again, it is the same 12-bit range. When I press the button, we see that the value then changes to 0. And then when I let go, it goes back to a state of 1. Then when I press and hold, it goes to a state of 0. Then when I let go, it goes back to a state of 1. Thank you so much for watching the video. If you found the video helpful, please let me know in the comment section below. Also, if you'd like to help the channel grow so that I can make more videos like this, consider checking out the PayPal donations link in the description below. Thank you so much. I will see you in the next upload.